knows a lot about the science stuff. Professor Dave explains.
Now that we know how fingerprint patterns form, it's time to examine the different types of fingerprint patterns. We already learned that there are three main types of fingerprint patterns, those being whorls, loops, and arches. Now we can examine their characteristics in greater detail. But before that, we need to familiarize ourselves with a few terms. These terms will assist us in defining a pattern. The type of fingerprint pattern is generally identified by determining the pattern area, the type lines, the core, and the delta of the fingerprint. What are these terms? Let us find out by looking at a particular fingerprint pattern. This is a loop pattern. As we have discussed previously, the lines of the fingerprint are known as ridges, while the gaps between them are known as furrows. The central and innermost part of something is called the core. Similarly, the approximate central point of a fingerprint impression is also known as the core. The next important part of a fingerprint is the delta. It is a point that is situated inside a triangular or funnel-shaped structure, which is a result of one of two possibilities. One, a single ridge bifurcating into two ridge lines. Here, the point of bifurcation is taken as the point of delta. Or two, abrupt divergence of two ridges running side by side. In this case, the point of divergence of two ridges is considered to be the point of delta. Now, look at the two parallel ridges adjacent to both sides of the delta. These ridges enclose the complete pattern and are referred to as type lines. However, they might be either continuous or disjointed, as their main function is only to confine the fingerprint pattern for identification. If a type line breaks, the next ridge is continued for consideration as a type line. If a type line bifurcates into two arms, the ridge that flows inwards is continued as a type line. The core, delta, and the ridges responsible for determining the pattern type are located within these type lines. Therefore, the area enclosed by the type lines is called the pattern area. Now that we've got the basics covered, we can understand how fingerprints can be classified using these terms. Let's start with loops. They are the most common fingerprint pattern of all, found in about 60 to 65% of all fingerprints encountered. Let's look at the same image we observed while defining delta, core, and type lines. We've already noted that this pattern includes one delta and one core enclosed by the type lines. The name loop means one or more ridges of the pattern enter through one side, curve around the core, and exit through the same side from which they enter. This is how a loop is formed. The delta is always present opposite to the direction of the ridge flow. Let us label the core as point A and the delta as point B. Now let us draw a line AB between the core and the delta. One or more ridges should loop around the core while also touching the line AB. Therefore, a loop can be defined as a type of pattern in which one or more ridges enter either side, recurve, touch or pass an imaginary line between delta and core, and tend to exit from the same side as the ridge entry. The loop pattern is in turn classified into two types, radial loop and ulnar loop, named according to the bones radius and ulna. They are the long bones constituting our forearms. While the radius supports the thumb side, the ulna supports the pinky finger side of the forearm. If the loop opens in the direction of the radius, it is called a radial loop, while if the loop opens in the direction of the ulna, it is called an ulnar loop. Look at your fingers and find a loop pattern similar to the one shown here. If the downward slope of the pattern is in the direction of the thumb, it is a radial loop, and if the slope is towards the pinky finger, the pattern is an ulnar loop. The second most commonly found fingerprint pattern is the whorl, found in 30 to 35% of all observed fingerprint impressions. Observe this impression closely. This pattern looks like a spiral and has a few ridges which complete a circle. Let us try to establish the core and the delta in this pattern. A core can be easily recognized as the approximate center in this type of pattern. Moving forward to the delta, this impression has two deltas, one on each side of the core, inside the type lines. Therefore, a whorl can be defined as a pattern having more than one delta and at least one ridge, making a complete circuit, which may be spiral, oval, circular, or any other variant of a circle. A whorl is also classified into different subtypes, plain whorls and composite whorls. The fundamental difference between a plain whorl and a composite whorl is that a plain whorl contains at least one ridge completing a circuit, but also touching the line drawn between two deltas. The one we just examined is a plain whorl. If we label both the delta points in this impression as point A and point B and draw a line AB, at least one ridge recurving into a circle will touch the line AB. On the other hand, composite whorls can be subdivided into a central pocket loop, a double loop, or an accidental pattern. Let's look at them individually. The first composite whorl pattern is the central pocket loop. If we look at this impression, it has two deltas and at least a single ridge that curves into a circular form, which are the two fundamental features for classifying a pattern as a whorl, but it can be distinguished from a plain whorl based on two major differences. First, the ridge or ridges completing a circuit do not touch an imaginary line drawn between the two deltas. And second, one of the deltas is more adjacent to the core than to the type lines. Overall, the ridges in this pattern flow like a loop, but also have a circular form around the core, which looks like a pocket. Hence the name central pocket loop. The pattern displayed here satisfies these conditions and is therefore a central pocket loop. The next type of composite whorl is a double loop pattern. As the name implies, it looks like a combination of two loop patterns in one fingerprint. One of the loop patterns may either flow into another loop or surround it. The only reason it is classified as a whorl and not a loop pattern is because it bears two delta points. Double loop patterns are further divided into two subtypes, a lateral pocket loop and a twinned loop. Let us look at these impressions side by side. The major point of difference in these patterns is that in the lateral pocket loop, the loops flow in the same direction, whereas in a twinned loop, the loops flow in the same direction, but one of them terminates abruptly due to the presence of a delta, as can be seen in the example. If we trace the outermost ridge for both of these, it will resemble the letter S. Therefore, twinned loops are also referred to as an S-shaped pattern. The last type of composite whorl is the accidental type. Such impressions can be a combination of loops, whorls, or arches. They are irregular, and their formation is a result of pure chance, found in only 1 to 3% of all observed fingerprint patterns. The conditions for identifying an accidental pattern are 1. The presence of at least two deltas, and 2. The inability to identify the pattern as any of the established patterns. As we can see here, they can be a combination of a loop and a whorl, a loop and a central pocket loop, a double loop and a central pocket loop, and so forth. The third and final major category of patterns is an arch. They are found in only 5% of all observed fingerprint patterns. Regarding the characteristics of an arch pattern, there is nothing particularly notable, and they are the simplest to classify. It has neither a core nor a delta. The ridges also don't recurve, unlike a loop or a whorl pattern. They simply look like the name suggests, arches. Ridges enter from one side, form an arch, and exit through the other side without redirecting. However, arches can still be classified into two subtypes, plain arch and tented arch. Though they look similar, the difference lies in the continuity of the ridges. Plain arches look like a wave where a steady flow of continuous ridges enter through one side and exit through another. In contrast, tented arches are characterized by a discontinuous flow of ridges. Here, the innermost ridges meet towards the center at an angle, forming a triangular or tent-like structure. With that, we have completed all the major fingerprint patterns and their subtypes. Let's summarize how to classify a fingerprint pattern based on delta and core. No delta, no core is an arch. 1 delta, 1 core is a loop. 2 deltas, 1 core is a whorl. One thing to mention here is that there are extensive rules to correctly identify a core and a delta, which might be beyond the scope of this series for a casual learner. Also, remember that this tutorial was only concerned with the identification of fingerprint patterns, which does not establish their individuality. In the next tutorial, we will discuss some features which actually make our fingerprints unique.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.